Now, this question is bringing together several topics that are important for rational functions, but one of the biggest things about it is that it is the type of question that you're just going to see over and over again. The first part is asking us what are the zeros of g of x? Well, the most important thing is when we hear the term zeros, that just means when does g of x equal 0? And what we know is that if the numerator equals 0, the whole thing is 0. The whole fraction is 0. So we want to find the times when the numerator will be 0. So for part A, we're looking at the numerator. And it's hard to tell right now in this numerator because the numerator is a quadratic function, x squared plus 15x plus 56. This is a little difficult to tell when it's going to equal 0, but I do know that we're probably going to have to factor it. So we need two numbers that multiply to make 56, but add up to make 15. Well, I know that 7 times 8 is 56, and negative 7 times negative 8 will be 56. Well, 7 times 8, or 7 plus 8, if we add them together, what do we want? We want it to be plus 15. 7 plus 8, well, that is 15. Negative 7 minus 8 is going to be negative 15, which means we want these two factors. That's going to help us here. And so, when we factor this, we're going to see that this is x plus 7 times x plus 8. Well, now we need to find the two values of x that are going to make this 0, and so we want to say x plus 7 equals 0 or x plus 8 equals 0. Subtract 7 on both sides. Here we get x equals negative 7. Subtract 8 on both sides, we get x equals negative 8. So, for part A, g of x has zeros at x equals negative 7 and x equals negative 8. So that's the first part of the question. The second part, part B, is asking us for what value of x does g of x have a vertical asymptote? Now a vertical asymptote, we care about the denominator. When will the denominator equal 0? Denominator equals 0, that means vertical asymptote. Asymptote. So what is our denominator? Well, that's x plus 5. Okay, so if x plus 5 equals 0, that's going to tell us our asymptote. We subtract 5 on both sides, x equals negative 5. That is our vertical asymptote. So g of x has a VA at x equals negative 5. Now the last question is the one that's the trickiest, but I think only tricky if you don't know how to solve it. The second you do, it's pretty straightforward. The last question is this. Describe the behavior of the function around its vertical asymptote. So I'm going to draw, here's a graph. We know that the vertical asymptote, like the question says, is x equals negative 5. So it's going to be like this. And the function is going to do a couple things. It might do something. It might look like this. It might look like that around the asymptote. Oh dear. It might also look like this around the asymptote. It might look like this around the asymptote. We don't know, but we have to test some values. And so let's try that. I see that negative 5 is right here, so let's see what happens on the negative side if we go more negative. Well, as we approach it from the negative side, from negative 5 there's negative 6 and negative 7. We're going to test out those two numbers in our value. So I'm going to write here testing as x approaches negative 5 from the negative side. When we do that, so let's test g of negative 6. So it's going to be negative 6 squared negative 6 squared plus 15 times negative 6 plus 56 over negative 6 plus 5. Negative 6 squared is 36. 15 times negative 6 is going to be minus 90 plus 56 all over negative 1. This 36 minus 90 is going to be negative 66 plus 56 is going to be, let me try this again. 56 plus 36 is going to be 80, 92. 92 minus 90 is going to be 2. So 2 over negative 1, that equals negative 2. So that means at negative 6, this is going to be negative 2. So it'll be like right here. Well, let's see what happens at negative 7 when we go more negative. G of negative 7 will equal negative 7 squared plus 15 times negative 7 plus 56 over negative 7 plus 5. Again, I'm getting this from the original function up here. So we do this. Negative 7 squared is 49 minus 105 plus 56. Negative 7 plus 5 is going to be negative 2. Now, 56 plus 49, that's 105. So that's going to be 105 minus 105 over negative 2. But that's going to be 0. And we know that because we already saw that the 0 was at negative 7 up here. So what do we see? We see that it's kind of behaving like this. It's going down, 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 and it's going to just keep going further down. It's not going to pick back up randomly. And so what we can say here is as x approaches negative 5 from the negative side, g of x approaches, is it going up or down? It's going down, so it's going to approach negative infinity. Now we want to test from the positive side too, so we're going to have to test two numbers here, negative 4 and negative 3. And if we test those values, we're going to plug those into the equation. I'm going to use the factored form of the function instead. Over here we factored this into x plus 7, x plus 8. That might actually make our math a little easier. So let's test negative 4. G of negative 4 equals negative 4 plus 7, negative 4 plus 8. I should draw something here so it separates. Over negative 4 plus 5. That's going to be negative 4 plus 7 is 3 times negative 4 plus 8 is 4 over 1, which will give us 12. So that means on this side, I see that it's going to be up here. What that tells me is that it's not approaching negative infinity, and in fact, I can probably just predict, kind of, that it's going to go up this way, because it's already so high up. And so that means we can say, we already have here, as x approaches negative 5 from the negative side, that g of x approaches negative infinity. And here I'm going to write, actually here I'm going to write, as x approaches negative 5 from the positive side. Let me change my color here, actually, so we can see this. Negative 5 from the positive side, that's here. G of x approaches positive infinity. And so the most difficult part of this is that you just have to actually test values. You can't just, like, know immediately. You have to try to plug some things in, and then you'll be okay. Rewatch this video a couple times if you need to follow along.